Hello students, welcome to our student support program for additional mathematics, grades 10 and 11. Our topic for today is series and we will be looking at the third part of the chapter geometric progression. So let us start. The objectives of today's lesson: to find the sum to infinity of a given geometric progression and to solve some problems involving the geometric progression. So, a recap on the notations to be used for a GP. The first term is denoted by A, the common ratio by R, the number of terms by N, the nth term is denoted by Tn, the sum of the first n terms will be denoted by Sn, and we will have a new notation, sum to infinity, which is denoted by S infinity. Now, the different formulae to be used for a GP, you will recall Tn is equal to AR power n minus 1, or Tn is equal to the sum of the first n terms minus the sum of the first n minus 1 terms. The formula for Sn, remember, for convenience we use Sn equal to A into 1 minus R power n over 1 minus R for R less than 1, and Sn equal to A into R power n minus 1 over R minus 1 for R greater than 1. And for the sum of the first n terms, R cannot be equal to 1. Now, for the sum to infinity, this is something new which we are going to learn in today's lesson. It is equal to A over 1 minus R. But we can only use this formula if R is greater than negative 1 and less than 1. So let us have a look at the first example. For each of the following GPs, we need to determine the sum to infinity if it exists. So part A, we have 8 to half. Our first term will be 8 and the common ratio will be 2 over 8, which is 1 quarter. And 1 quarter is found within the interval for the sum to infinity to exist. That is, remember, R should be greater than negative 1 but less than 1. So here we can find the sum to infinity, which is A over 1 minus R. That is 8 over 1 minus 1 quarter, which is 10 2/3. Part B, 4, 6, 9. Our first term, A will be 4, and R will be 6 over 4, that is 3 over 2. Now, R is greater than 1, therefore the sum to infinity does not exist. Part C, 0.1, negative 0.2, 0.4. So here A is 0.1. R will be negative 0.2 over 0.1, which is negative 2. So here R is less than negative 1. Therefore, the sum to infinity does not exist. Part D, 9, negative 6, 4. So our first term will be 9. Our common ratio will be negative 6 over 9, which is negative 2/3. Since R is found between the value negative 1 and 1, the sum to infinity exists, and we can find it by replacing the value of A and R into our formula. So we get sum to infinity equal to 5 2/5. We now move on to example 2. The second term of its GP is 2, while the sum to infinity is 8. Find the sum of the first 8 terms. So here we have been given the second term is 2. That is, we are going to use Tn, which is equal to a r power n minus 1. So T2 is 2 means ar equal to 2. This is my first equation. The sum to infinity is 8. That is, I replace in my formula a over 1 minus r equal to 8. A equal to 8 into 1 minus r, which is my second equation. So here I will substitute equation 2 into equation 1. I will have 8 minus 8r into r equal to 2. Simplifying, I get 8r minus 8r squared equal to 2. I send all the terms on one side and I divide by negative 2. I get 4r squared minus 4r plus 1 equal to 0. I factorize. I get 2r minus 1 to the square equal to 0. So r will be equal to half. I now substitute the value of r into equation 1 to get the value of a. So here a is equal to 4. Now I need to find the sum of the first 8 terms. So here r is half. I will use this formula since r is less than 1. I replace r by half and a by 4 to get S8, which is equal to 7/31 over 32. Moving on to example 3. An infinite geometric series has a finite sum of 256. The sum of the first 3 terms is 224. Find the value of the third term. So let us have a look at the solution. The sum to infinity is 256. That is, a over 1 minus r equal to 256. And I call it equation 1. Then the sum of the first 3 terms is 224. So I replace in my formula a into 1 minus r cubed over 1 minus r equal to 224. I substitute equation 1 into equation 2. And I will get 256 into 1 minus r cubed equal to 224. So what I have done here, I have replaced a over 1 minus r in my equation 2 by 256. Expanding or simplifying first, I get 1 minus r cubed equal to 224 over 256, which is 7 over 8. Therefore, r cubed will be equal to 1 over 8. Taking the cube root of 1 over 8, I will get r equal to half. So now I find the value of a. Therefore, I substitute the value of r into equation 1. A will give me 128. I need to find the value of the third term. So I will use the formula for Tn. T3 will be equal to a r squared. I replace a by 128 and r by half. So T3 will be equal to 32. Moving on to example 4. The sum of the first and second terms of its GP is 10, while its sum to infinity is 18. if this GP contains both positive and negative terms, find the fourth term. Show also that the sum to 8 terms differs from the sum to infinity by less than 0.71. So here we have been given the sum of the first and second terms of a GP is 10. So I have used T1 plus T2 equal to 10. That is A plus AR equal to 10. And I factorize A into 1 plus R equal to 10. And I call it equation 1. Now the sum to infinity is 18. I replace in my formula A over 1 minus R equal to 18. So A will be 18 into 1 minus R. And I call it equation 2. Now I substitute equation 2 into equation 1. I will get 18 into 1 minus R into 1 plus R equal to 10. I divide by 18. And 1 minus R into 1 plus R is 1 minus R square. So 1 minus R square will be equal to 10 over 18, which is 5 over 9. R square equal to 4 over 9. And R will be equal to 2/3 or negative 2/3. Now in this question, we were given the GP contains both positive and negative terms. So this means that here R must be negative. So I replace R, which is equal to minus 2/3 into equation 2. And I get A to be equal to 30. Now I need to find the fourth term. So T4 will be AR cubed, which is equal to negative 8 over 9. Now there is a last part to this question. Show also that the sum to 8 terms differs from the sum to infinity by less than 0.71. So first I need to find S8. So A is 30, R is negative 2/3. Replacing in the formula for Sn, I get S8 to be 217 over 729. Now we were given in the question that sum to infinity is 18. So I find S infinity minus S8, sum to infinity minus the sum of the first 8 terms, which is equal to 0.70233, which is indeed less than 0.71. So here are some questions for you to practice. The first one, find the common ratio and the sum to infinity where it exists. Then you have a few word problems. So in today's lesson, we have learned how to find the sum to infinity of a given geometric progression and how to solve some problems involving the geometric progression. So until we meet again, it's goodbye.